Hi, in this video, we're going to take a look at how to do an application called the Ferris wheel to determine a trigonometric function. Here is the problem we're going to take a look at how to solve. A Ferris wheel of diameter 18.5 meters rotates at a rate of 0.2 radians per second. If passengers board the lowest car at a height of 3 meters above the ground, determine a sine function, or cos function perhaps, that models the height h in meters of the car relative to the ground as a function of time t in seconds. Here are the clues provided in the question. The diameter of the Ferris wheel is 18.5 meters. It rotates at a rate of 0.2 radians per second. The passengers board the lowest car at a height of 3 meters above the ground. Calculations. First of all, here is a review of the diagram. The axis of curve is shown in red. The distance from the ground to the minimum point of the Ferris wheel is 3 meters. The distance from the minimum point to the center of the Ferris wheel is the radius of the circle. Radius is determined by taking 1/2 of the diameter. So the radius is 1/2 of 18.5, which is equal to 9.25. C then has the value 3 plus 9.25, which is equal to 12.5. That means the distance from the ground to the middle of the Ferris wheel is 12.5 meters. The amplitude, shown in green, is the distance from the axis of curve to the top of the wheel. Now, we know the radius is 9.25, so that means the amplitude is 9.25. Now, let's find the K value. A circle is 2 pi radians, which happens to be 6.283 radians as a decimal value. Our Ferris wheel rotates 0.2 radians per second. How long then will it take to rotate 2 pi radians, which is one circle, 6.283 radians? To find this out, you're going to set up a ratio. 0.2 radians takes 1 second. 6.283 radians takes, therefore, x seconds. 0.2 to the ratio 6.283 is equal to 1 over x. Now we cross multiply, so x will equal 6.283 times 1 divided by 0.2, which is 31.42 seconds. So K is equal to 2 pi divided by 31.72, which is equal to 0.2. Now, let's talk about the phase shift, which is your D value. Typically, the sine function begins at the middle right. Typically, the cos function begins at the highest point. If you reflect a cos function, that means flip it, The graph starts at the value of the lowest point. Since this cycle starts at the bottom, that's where the user gets on, there will not be a phase shift, but we could use a cos function reflected. Now, let's put it all together. H height equals negative, because it's a reflection around the x-axis, 9.25, which is the amplitude that we found. We know it's a cos function because it began at the bottom, so it was reflected from the top. 0.2, which is our k value. T is our unit of measure, plus 12.25, which is our axis of curve measure. Now, let's act like a wheel and roll on over to the next question. See you there.